So today we're going to cover the last section of chapter 7. Today we're going to learn about trapezoids and kites. Now, both of these types of figures are not parallelograms. They're quadrilaterals. They have 4 sides, but they do not have 2 pairs of opposite parallel sides. So let's see what a trapezoid is by definition. So a trapezoid is a quadrilateral with exactly 1 pair, so this is important, only 1 pair of parallel sides. That's why it's not a parallelogram. Each of the parallel sides is called a base. The non-parallel sides are called the legs. Base angles of a trapezoid are 2 consecutive angles whose common side is a base. So we could have 2 sets of base angles. So we can have, even though it's not sitting on the bottom, I've got base angles here and also down here. So the base is going to be the parallel sides. And then the non-parallel sides, those will be the legs. Slide. They're talking about a special trapezoid, and this one's called an isosceles trapezoid. So if the legs of the trapezoid are congruent, then the trapezoid is an isosceles triangle. Notice the congruency marks on the legs. So it's showing that this leg is congruent to this leg, making this an isosceles trapezoid. Just like we had an isosceles triangle, 2 sides are going to be congruent. Next, we're going to see some theorems about the trapezoids. So the first one is the isosceles trapezoid base angles theorem, just like you had the isosceles triangle base angles theorem. Here it said, if the trapezoid is isosceles, then each pair of base angles is congruent. So remember, the bases are the parallel sides. So we have base angles at B and C that are congruent, and then base angles at A and D that are congruent. Then the converse of that is if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So here, if they're showing you that you have a pair of base angles that are congruent, then you can determine that this trapezoid is isosceles. And then, yes?
So you don't need both pairs, people?
Just one. Because if you recall, if we had parallel lines here, this could be a transversal, and then these angles here would be same side interior. So if this one, let's say, is 70, then we know that this one's going to be 110, and then same thing here. So it's automatically going to make the other ones congruent. All right, now the last one here on this slide is the isosceles trapezoid diagonals theorem. And this one states a trapezoid is isosceles if and only if its diagonals are congruent. So the only time the diagonals of the trapezoid are congruent is when it's an isosceles trapezoid. If it's just a regular trapezoid, the diagonals will not be congruent. Pretty good here? Okay, let's go on to the one. Here we're talking about the mid-segment of a trapezoid. We had a mid-segment of a triangle. Now we have the mid-segment of a trapezoid. And it's going to be the segment whose endpoints are the midpoints of the legs. So you would find a midpoint over here of this leg and a midpoint of this leg. And that's where the mid-segment goes through. Notice the congruency marks indicating that this point is a midpoint. This is congruent here as well as over here. Now these 2 legs aren't congruent to each other, but it does separate that leg into 2 congruent pieces because it's hitting it at the midpoint. Next slide is the mid-segment theorem. So the other one tells how it's created, the definition. Now it's telling us how we can figure out how long it is. So the mid-segment of a trapezoid is going to be parallel to each base, and its length is going to be 1/2 the sum of the lengths of the bases. So we're going to add the top plus the bottom and then divide by 2. And that's how I can figure out how long that blue line is, that mid-segment. So you could also think of it like this. You could say that this is base number 1. Do it in a darker color. You could say this is base 1, this is base 2, and then you can add them, base 1 plus base 2, and either think of it as divide by 2 or multiply by 1/2. This is similar to the trapezoid area formula. The only thing that's missing is multiplying it by the height. So to find the mid-segment length, you add the two bases and then divide by 2 or multiply by 1/2. So these are all the special properties of your trapezoids. Yes?
If this was an isosceles trapezoid, would all 4 of the mid-segment pieces be congruent?
Correct. Yes, because our legs would be congruent if it was isosceles. Yes, absolutely. Everybody good on this slide? Okay, let's talk about kites. So a lot of you don't realize that a kite is actually a quadrilateral. It actually looks like a kite that you might fly in the sky. So a kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. So the sides that are right next to each other, those are the congruent ones. So this one is congruent to this one, and then this one would be congruent to this one. So now we're going to see properties of kites, again presented as theorems. Again, the numbers are not important to us, just understand what they say. So a quadrilateral is a kite. If a quadrilateral is a kite, then its diagonals are perpendicular. So just like the rhombus in the square, the diagonals of the kite are going to be perpendicular. The second theorem, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. If it had both, then it would be a parallelogram, and a kite is not a parallelogram. So this word exactly 1 is important. So here, angles D and B would be the congruent angles. A and C would not. So now let's try some applications of everything that we just learned. So again, my advice to you is as you're getting ready for this test, make yourself a nice maybe paper where you have all of these properties of all of the quadrilaterals on it. Whether you use the Venn diagram that I showed you the other day for the parallelogram, the square, the rectangle, the rhombus, and now we have added in these other 2 quadrilaterals, trapezoids, and kites. So let's try some examples. So we have a trapezoid here. Notice here, now sometimes your trapezoid is not going to be sitting on its bases. Remember, the bases are the parallel sides. So this is a base and this is a base. So maybe if it helps you to see it, sitting on its base, you could always redraw it. But just remember, it may not be presented to you sitting on its base. So let's say I flip it over. And I'm not in Notability, so my picture is not very good here. So here's my trapezoid flipped over. Now I have it sitting on its base. And I was also told that, let me go ahead and add in the letters here. So I have C, D, B, A. And this one up here was 100 degrees. So because it's a trapezoid, I know I could go ahead and figure out, because these have congruency marks here, I know my base angles are going to be congruent. So I know this one's congruent to this, so this would be 100. And then these down here are going to be congruent. And if you think about this as being parallel lines, it's got the arrows on it, and then here is my transversal, these two angles here, C and B, are going to be supplements. So to figure out how much angle B is, I can do 180 minus 100, and it's 80 degrees. So this angle's 80, and so is this one. You could double check everything, and you can make sure that they all add to 360. You could have also added the two 100s and done 360 minus 200, leaving you with 160, and then divide that by 2. This is another way that you could have found out those other two base angles. So the measure of angle A is going to be 80 degrees. And again, remember, they don't always have the picture sitting on its base. Look for those parallel marks. Those are going to indicate that those are your bases. Let's try the next one. It is sitting on its base. Notice the parallel sides. Notice I also have congruency marks here, indicating that this is an isosceles trapezoid. So in addition to angle H being 49, I also know angle E is 49. Okay, so let's go ahead. They want us to find the measure of F. So I already can see, I can do this several different ways. If I know that the four angles of a quadrilateral add up to be 360, and I already know two of them, I could do 49 plus 49, or 49 times 2, either way. I can get 98, subtract that from 360, and this leaves me 262. Now that's what's left for both F and G. Then I would have to divide it by 2, and I get 131. Now also realize that, again, you have parallel lines here, and this is also a transversal. So you could have also just done 180 minus 49 and got 131. So you can do this either way. The two missing angles are 131, but it only asks for F, so the measure of angle F is 131. So when I have a quadrilateral, or if I have parallel lines, so the two green ones are parallel, and then this is the blue one is my transversal. These two angles that are right here are same side interior angles, and same side interior angles are supplements. So if I knew this one was 49, to find this one, I just have to subtract it from 180. So I'm going back to my stuff before Christmas. So you can go about finding F and G either way. Let's try example 3. Another trapezoid sitting on its base. I've got congruent legs, so this is an isosceles trapezoid. So let me go ahead and label in my picture what I've been given. So they gave me KB, and KB is right here. And they're telling me that has a length of 21.9. Then they also gave me MF, which is this whole diagonal. So this whole thing is going to be 32.7. They want me to find the length of FB, and FB is right here. Now, because this is an isosceles trapezoid, I know that the diagonals are congruent. So if I know that this piece over here in red is 21.9, then I also know that this piece over here is also 21.9. And if I know the entire length of the blue one is 32.7, to find that little missing top piece that I went over in yellow, I just need to do 32.7 minus 21.9. So let me go ahead and do that. 32.7 minus 21.9. And I get, no, I didn't need to borrow. I did. Everybody understand that? In the trapezoid, the diagonals are not bisected. The only thing we know about diagonals is when it's an isosceles trapezoid, and then these diagonals are congruent. So all these little pieces that were made, the little red piece, the yellow piece, these are not congruent to each other, but the big longer pieces are. Because I know the entire diagonal from K to J is congruent to F to M because it's isosceles. So the missing piece of FB is 10.8. This is a linear measurement. It's not, doesn't have a degree symbol. Let's do some examples with kites. So in kite ABCD, the measure of DAB is 54. Let me go ahead and label that. So this one down here, this whole thing is 54 degrees. And CDF, just this little piece over here, is 52. It wants me to find the measure of BCD. So BCD, let me do that one in red. BCD is over here, this whole angle. This is what we're asked to find. So let's go back through and let's figure out what we have going on. So we know that a kite only has one pair of congruent angles. So what we can do here is, because I know that a kite has consecutive sides that are congruent, I know that this side is congruent to this side, and I also know this side is congruent to this side. I also know that the diagonals are perpendicular. Now, angle BAD and BCD, which is what they're asking me to find, are not the congruent angles. The congruent angles are these right here. It's where the two non-congruent sides meet. So what I'm going to do here is I can use a lot of my triangle information to find some of this. So let's see what we can do here. So because what I could do here is think of this triangle, just this little tippy part of the kite. I could say that this is an isosceles triangle. So then I know that this angle over here is 52 because it's congruent to the green one. The base angles are congruent if the sides are congruent. So then now what I can do is I can figure out what I got going on here. So far, I could do 52 plus 52, and I get 104. And then what I can do is subtract that from 180. Giving me 76 degrees, which is the measure of the angle I'm looking for. Because that's going to give me, I'm talking about the yellow triangle. So if I know that these two base angles are 52, then this vertex angle up here is just going to be 180 minus those two 52s, and it's 76 degrees. So BCD is 76. Now, another way you could have gone about doing this same kite, let me maybe redraw it here. There's other ways to do it. So let's say we had our kite over here with our diagonals. And let's just talk about this triangle up here. So if I knew this angle right here was 52, and if I knew that this angle right here is 90, I could have found this missing one, and I could have subtracted it from, I could do 52 plus 90, get 142, subtract that from 180, and the missing angle up here would have been 38. And again, this is the same. So this side would also be 38. So you could just do 38 plus 38 and get 76 that way as well. So again, more than one way to go about finding these missing measures. Again, we're bringing back a lot of prior knowledge that we learned before Christmas. Yes?
Is there anything parallel in a kite?
No.
There's only one group on the test.
I don't know yet. We haven't finalized it yet. There could be two. We're not sure.
Okay.
All right, let's do one more example. It's a word problem. It says Lucy is framing a kite with two wooden dowels. So a wooden dowel is like a stick, like the sticks of your kite. She uses two dowels that measure 18 centimeters, one dowel that measures 30, and two dowels that measure 27. So the 18 and the 27, these are forming these outside edges of your kite. Then the one that measures 30, that one is going to be this stick that's in the middle here. So we can see that there's going to be 15 on this side and 15 here. It says to complete the kite, she needs a dowel to place along KL. So we need to figure out this one right here. And she has a dowel that's about 36 centimeters long. How much wood will she have left after cutting the last dowel? So what we're going to be doing here is, this would actually be a calculator question. So you would be doing Pythagorean theorem, because remember the diagonals are gonna be perpendicular. So what I can do is realize that you have a right triangle going on here. So I'm gonna do Pythagorean theorem for this triangle. And I can do a squared. Let's see, let me go down here where you can maybe see it a little bit better. So I'm gonna be doing a squared plus b squared equals c squared. So a squared, I'm gonna say that's what I'm solving for. B squared, I'm gonna say is the 15. And then the hypotenuse is that 18. So 225 equals 324. Gonna subtract 225. A squared equals 99. So since I'm trying to approximate this, I'm gonna square root this. And the square root of 99 is about 9. I'm going to round it to about 9.9. So this little piece of the kite is about 9.9 centimeters. Now I need to do the same thing for this triangle. And again, I'm going to do Pythagorean theorem again. So for this one, I'm going to do a squared plus 15 squared equals 27 squared. 15 squared, 225. 27 squared, 729. Subtract. A squared equals 504. Square root both sides. And this time, this little piece is going to be around 22.4. So this piece of the kite of KL is 22.4. Now I'm going to go back and add these two and figure out how much I'm going to have left. So 9.9 plus 22.4, and you get 32.3. The question was how much, it wasn't how much do you need, it's how much will you have left. So we're going to take that 36 centimeter long dowel and subtract 32.3. And I get 3.7. So about 3.7 centimeters. That's how much wood she would have left. So again, we are allowing you to use calculators on the test. I even enable it on the lockdown. So if you do get a word problem, you would just if it said about, you could round it to the tenths place. So that is it for chapter 7. So you have homework for 7.5. I also have the review for the test already released. So for those of you who want to start looking at the review, the test is Friday. So test is Friday on all of chapter 7. Again, I don't know how many proofs we're going to put on it. There'll probably be at least one. This chapter is always good with sometimes always or never questions. They can get kind of tricky. So you've been having the sometimes always or never questions in the homework, so make sure you are aware of the properties. Yes?